So now is the live demo part. So I really want to show you everything live so that you can see the true experience. The first one is the CMAP. This is really to show a region-wide all the corridors based on the trajectories and that CSP I showed you earlier, how they are performing. And then I'm going to show you this Compass WaySync workflow using a real case. So the real case is in Boca Raton. Okay, so I'm going to now turn everything live. Yeah, first is the CMAP. I want to show you how does CMAP looks like. So this is where Boca Raton is. Okay, in Florida. These are all their major corridors. You can see on the right side. Yeah, we can do multiple years. This is based on 2025, the connect vehicle trajectories. You can look at each time period, AM, midday, and then you can also select which performance measure you want to see. CSPI is the main one. We also have this, we call it the GR ratio. So what is GR ratio? It's a green-red ratio. You can see the definition here. So on average, the number of green lights per red light encountered if you drive through a corridor. So users can easily see this. So if it's for good signal timing without oversaturation, so you must have some number in mind. What would be a good number for the GR ratio? Okay, so at least this is what is showing for their corridors. But looks like so a lot of improvement can be done. So eventually we select this one, this federal highway corridor. The reason we select this one is that at least the cycles are consistent, pretty much consistent, versus I look at all the other corridors. So each corridor has several different cycles. So obviously that will affect the performance. Okay, so I'm going to use this corridor, Federal Highway, a segment of it, to show you how the before timing looks like and how the optimization is done. And then I'm going to pull out the before-after trajectories from Compass and then show you a before-after comparison. So here is the actual corridor segment, 11 signals. So I'm going to open the before timing. So this is their before timing, okay? You look at the time space diagram, this is going northbound, the blue, green is going southbound, okay? You look at the cycle, this is the cycle, 150, 150, 75, which is half cycle, and here's 160. The rest is all 150. So that's why I'm saying the majority are running a common cycle, except this one. So Yamato is a major crossing arterial. So that's the existing timing, 160 seconds. So, with the 160 there in the middle, of course, is going to disrupt the progression. And first, the city manually collected these runs. So these are manually collected, the trajectories, okay? Because this different cycle in the middle, so the trajectories, we couldn't put them, together because the trajectories, we still try to match the time space diagram, okay? So this is what manually collected. The reason we did this manual collection is to make sure if we get the trajectories from connect vehicle data, somehow they're compatible. So that's the whole reason. Here, I just want to play one run. So in case you are not familiar or you have not seen WaySync before, to show you how the trajectory match the time and space diagram. So we started from upstream. Keep in mind we're going north, okay? And you can see based on this projected, so I can put a kind of a trajectory here. Okay, so it won't be able to make it. So you can see that turned yellow. Okay. The red means the side street is on. So you can see the side street is on. That's the maximum split. That is phase 4, which is 40 seconds. So the time is right here. If there are continuously there's traffic, it's going to max out, or it can gap out if there's no more cars. So you can see, okay, it's right now, okay, there's another car. Now you got the left turn through. It's supposed to be dual left turn because opposing, you see there's no left turn vehicle there. That's why skip that left turn. And you can see the next one should be green by the time it gets there, which by this time is already green, so should be able to go through. So to save some time, I'm going to play just at a higher speed. So at least give you an idea. This is how a real run trajectory matches a time-space diagram. Okay, so the two left turns should be on at the same time, and then you pass through this one. Should be able to go through this one. Should be able to go through this one if you just project the vehicle travel. And then here, depending on if you don't get early return, you will stop. And if you get early return, you could go through, but these cars get stuck behind the queue. That's why you see the vehicle stop there. And then by this time should be green, made it through. Okay. I can fast forward a little bit. Okay. Okay. Went to the beginning. Okay. Anyways, you can see this one. Okay. Play a little faster. Again, if you don't get early return, it's going to stop shortly. If you can get early return, actually a little bit early return, but because of the queue, still made a short stop. Now this one, you hit a narrow band and just turn yellow. Okay. So if the time is running according to the time space diagram, the trajectories should match the time space diagram. Okay. Now let me, oh, I forgot to show you the exactly how the optimization was done. Okay. I'm going to open this again. So the first thing we did was to change this to a common cycle, which is 150. What we did was, because it's going to affect the crossing arterial, so this is the intersection, okay? What we did was, so these three intersections, kind of a short segment, traffic is not heavy, and on the west side, traffic is heavy. So we made a change on these three signals to have a cycle of 150, okay? So I'm going to open the time space diagram again. So the first thing we did is to change this to 150. But these are the previous splits. Remember, one is 17 seconds to 80, 4 is 45, so 6, 5. So these are the previous. So now we are going to change to 150. 150 seconds, okay? So one is still 17, 2, we made it 74, so 4, we made it 43. Basically, we try to proportion reduce from each phase. And then also we try to, previously phase 8 anyhow won't accommodate the pad. So here with 150, it won't accommodate the pad. That's why you see the red. Everywhere else, we try to accommodate the pad. So it just based on the current split, proportionally reduce. So now we get up to 150. Now the cycle length is consistent, and we can just run a, before I run the optimization, okay, I need to point out there are 5 intersections on this corridor. It's running protect permitted left turn, which is also using the 5-section head. So they're not using flashing yellow arrow. So you all know with the 5-section protect permitted left turn signal head, you cannot really run the lead lag. You are going to get into the yellow trap. So we have to lock those intersection sequences, like anywhere you have PPLT. Okay, we need to lock the sequence to make sure you don't run lead lag. Okay, so these 5, after we lock the sequence, then you can just quickly run a bandwidth optimization without changing the cycle and the split. So therefore, there's no need to collect the volume. So this is the optimization, initial optimization we get. Okay, by looking at this, you can see going southbound. The green starts here. You are going to immediately hit a stop, a red. Okay, so we did make some adjustment. One adjustment is, make sure you don't stop there when you get started. Okay, and also we try to kind of align the southbound to provide a better southbound band. So something like this. Okay, so we put it on, let it run for a month, and we made further adjustment based on where the phases you get early return, all those things. So next time I'm going to show you just the final optimized and the before timing. So this is the before. I'm going to put it up here. Okay, this is the after. Okay, you can see this is pretty similar to what I showed you earlier. So it didn't take very long to come up with a new timing. So this is the after, this is the before. Now, next, I'm going to pull out the trajectories, okay, from compass. Okay, this is compass, what you are seeing here. So the timing we did, the first initial timing implementation was around the end of April, so this year. And we did some fine tuning. So the final timing was implemented on May 26th. So I'm going to pull out the before timing, which is from just 2 weeks in April. So April 1st, April 15th, okay? So that was before. And also we are only looking at, this is a midday, okay, only weekdays. And the time is from 10 to 3 p.m. So that's when the midday plan is running. So this is the first time period, the dates, which is before. Now I'm going to do another one, which is the after. June 1st, I'm going to pick another 2 weeks in June. Okay, do the same thing. Okay, only weekdays. And then the time period also from 10 to 3. So now we got the 2 before after days. And the next, I'm going to draw the trajectories. So the segment is this one. This is Federal Highway, somewhere from here to here. Okay, so I'm going to draw 2 trajectories, not trajectories, 2 paths. Okay, so starting here, this is the last signal, and here. And then I'm going to draw another one from here to here. Okay, I can name this This is northbound, okay, and this is southbound. Now I'm ready. Just pull out the trajectories. It takes some time. Shouldn't take too long because I only select 2 weeks. So now it's ready. So view the results. Okay. So yeah, there are some other things you can see if I scroll down here. This is the trajectory part, okay? There are some other things, so I'm not going to get into those. Now, how to get those trajectories into WaySync? So this function, so we have this integrated with the WaySync and the Compass. Just say select WaySync GPS. By selecting this one, so it's downloading, okay? It's going to download a zip file. Hopefully it's doing it. Yeah. Okay. So here is the file. Okay. It's here. It's a zip file. So I'm going to unzip it. Okay. Now you see there are 2 directions, southbound. There are 2 folders. I believe this is the one. If I double click, you will see these are the individual trajectories. It will tell you the date and the time. So this is the after. Okay. So this is one improvement I have informed them to. Instead of just use those random numbers, put the actual date. So that is after, this is before. And then we go to the northbound. So that is also the after. And this is before. Okay. Let's just double check. So this is, yeah, after. So now we are ready to just load this to WaySync. So I'm going to load the before at GPS, and is under here, downloads here. Let's do northbound first. That is before. Okay, so select all these trajectories. And then I'm going to do the southbound. Also the before. Select all these trajectories. Okay. Select all, show. So these are the trajectories, okay? Like I said, because the different cycle, remember this is running 160, the other is running 150, so we couldn't put them together. Now I'm ready to load the after. So add, okay, so southbound after first, and then we do the northbound. Okay, now we go back to the northbound after. Select all, show. Okay, now you see this is the after, okay? to compare, make a comparison of the score. So we can produce a report here. Yeah, this is actually the before, this is the after. Okay. And you can look at that a comparison. Before the score was a C minus, after is a B plus. Okay, green red ratio before is 2.1, now it's 4.4. Travel time before is 591, average of both directions. Now it's 491. So we reduced by exactly 100 minutes, 100 seconds. So by direction, you can also see it by direction. Okay, so this is the before, after. Okay, from this, we can also do a quick benefit calculation. So by, before, after. So you look at based on these trajectories. So this is what you're going to see. Okay. These are the assumptions. Time value is I used $20 an hour, a fuel $4 per gallon, operating days 250 days, and the maintenance. And then you can compare before, after, travel time before, travel time after, speed before, speed after, stop before, stop after. And economic savings is $2.3 million. Okay. I think I finished the live demo in time, and we still have 15 minutes. I think this is now a good time for you to ask any questions.